It says in the triangle OAB, the angle OAB is 90 degrees. Okay, so you can just simply visualize, no marks given for diagram. OAB is 90 degrees. So just make sure that your 90 degrees happens at the vertex A. And the point C is on AB, such that AC equals to third CB. AC is equals to third CB. It's a bit hard to interpret like this, so I will just convert it into ratio form on both sides. So I have AC ratio CB is 2 ratio 3. Okay. And then now it's clearer. AC will take 2 portions, CB will take 3 portions. And you have the triangle OAB. Okay, the position vectors of A and B are given as small a and small b respectively. Okay, so you are actually given OA is denoted by small a, OB is denoted by small b. Okay, find the position vector of C. This question is a bit incomplete. What they really mean is in terms of A and B. Okay, so please add in this phrase here. Okay, so they want us to get OC. Okay, OC in terms of small a and small b. So first of all, we can find a convenient path to OC first. Say OC can be taken as OA plus AC. Okay, OA can later be replaced by small letter a. Okay, but then AC, we want to express it in terms of small letters a and b. So ideally, we want to first express AC as a portion of AB. AC as a portion of AB. Okay, so we know AC goes this way. AB is just AC extended to a longer length. Okay. If AC takes 2 portions, and CB takes 3 portions, so overall AB will take 5 portions. So in other words, AC will be 2 over 5 of AB. AC will be 2 over 5 of AB. AC and AB are pointing in the same direction. And that's why this scalar here is a positive number. So AC is 2 out of 5 portions of AB. So this is plus 2 out of 5 of AB. So for the vector AB, I will have OB minus OA. Okay, now we change everything to small a and small b. This will be 2/5 b minus 2/5 a. Simplifying the coefficients, you have 3/5 a plus 2/5 b. Okay, and that's it. And that's the answer for OC. OC will be understood as a position vector of C. Even if we don't mention the word position vector, OC is understood as a position vector of point C. And that's it. And this is example 4, and we are done with example 4 now. Okay, next moving to example 5. Okay, this is just for you to practice looking at a three-dimensional diagram and write vectors based on the diagram. And write expressions for vectors based on the diagram. So you are given PQR in the directions as indicated in the diagram. And then they wanted to express the following in terms of PQ and R. Now, this is a prism. So you have all heard before the word prism. A prism means the cross section of the solid will be the same. So for a prism, with the sides B, G, C, H, D, I, E, J, and so on, this, they will all be parallel. They will all be parallel. And then only you can get a consistent cross section. Then they also say the hexagonal cross section is regular. So the cross section is in the shape of a hexagon. Regular here means the side lengths of the hexagon are the same, which means you have A, B, B, C, C, D, D, E, E, F, and F, A having equal lengths. And they also tell you that AD is 2 times of BC. Okay, so by this equation, we know that AD and BC are pointing in the same direction. AD is 2 times of BC. Yeah, and you are given AB, BC, and BG as small letters PQ and R as shown in the diagram. Okay. So part 1. But to get the vector AC, we just find a convenient path, preferably involving those sides with known vectors. Okay, so we have AB and BC, these two are known as P and Q already, so this is a convenient path to take. AB plus BC, that will give us P plus Q, okay, and we are done. Part 2, to find AD. But AD, the question says it is 2BC. BC is given as Q, so just write Q and we are done. Okay, so answer is 2Q. Part 3 is HI. Okay, so where is HI? HI is this side here. Okay, the side that I draw in green, directed, slanted downwards. Okay. Recall that vectors are free, so you can always move it around. And so this vector, if you maintain the direction and line, you can actually move it here. You can actually move it here. So HI and CD are the same. HI is equal to CD. Hey, why we want to move it in front? So that it's easier to involve P and Q. Okay, so to get from C to D, we can take a long path. Going from C to B, from B to A, and from A to D. CB plus BA plus AD. Now what is C to B? C to B is the opposite of BC, so you have negative Q. And BA is the opposite of P, so we have minus P. And then AD earlier we have, from the answer in part B, you have plus 2Q. So you end up getting minus P plus Q, and done. Okay, let me just paste the diagram down so that I don't have to keep scrolling up and down. Okay. Part 4, the vector from I to J. The vector from I to J, you can move it to the front. Diraj asked the arrangement of the terms, whether you write uh, Q minus P or minus P plus Q, both are equally good. And the order doesn't matter. Right, coming to part 4 asks you about IJ. The IJ, you can move it to the front, it will be D to E. Okay, and DE, you can also move it up there. It's the same as B to A. Because the hexagon, because in a regular hexagon, your DE and BA will have the same direction. Right, so it's the same as BA. Okay, and what is BA? BA is opposite of P. Okay, and that. Next is part 5, EF. EF will be this way, going from right to left. Okay, so you can move it up as C to B, and that will be minus Q. Okay, done. Part 6. Okay, where is B to E? B to E is this diagonally downwards. It's this diagonally downwards. Okay, so let's find a path to reach E from B. You can take B, C, D, E. You can take that path. You can take this yellow colored path. So it's BC plus CD plus DE. Okay, so what is BC? BC is Q. Okay, what is CD? CD has actually appeared before earlier. CD appeared here in part 3. And so we can actually use that information. CD is minus P plus Q. So let's use that. Okay, and what is DE? DE, I think we have also, it has also appeared before. It's up here. So DE is actually negative P. So I plus with negative P. So simplifying the terms, you get 2Q minus 2P. And done. Okay, for part 7, you have AH. Where is A to H? It will, this straight line AH, it will pass through the interior of the shape. It will pass through the interior of the shape. So let's find a path that is convenient for us to use. You can take A, B, B, G, G, H. Okay, AB is AB is clearly P. BG is given as R, while GH is the same as BC. Okay, so you have P plus R plus Q at the end, and done. If you want to rearrange it as P plus Q plus R, also can. And finally, Fi. So referring to the last diagram down there, where is Fi? It is this diagonal that passes through the interior of the shape. Okay, so let's find the path that is convenient. I choose to take the path F E E J J I. You can of course take a different path like F E E D D I would also work. As long as the path is continuous, it's a continuous path. So you have F E plus E J plus J I. F E can be brought up to BC. EJ is actually the same as BG. The direction are the same and length is also the same. EJ is the same as BG. And JI is the same as AB. So BC is Q, BG is R, AB is P, and done. So you can of course rearrange as P plus Q plus R if you like. And that's it. But to those who joined the class late, please remember to watch the recording for the part that you missed. Okay. Now let's carry on with example 6. Yeah, the questions here are still rather simple, so I will be quite fast. So you are given position vectors. PQ can be written as O to the end point minus O to the starting point. We covered this in the previous lesson. Any vectors can be written as O to the end minus O to the start. So just sub in the values. Okay, that's it. Okay, whether or not you want to convert it into the IJK form, this would be 3J minus 6K. If you want to convert it to IJK form, this is optional. Because the question didn't say that your answer must be in terms of IJK. So whether you want to leave your answer in the bracket form or in terms of IJK is up to you. It's not a must to convert to IJK unless the question specifically asks for it. It's optional to convert. Okay. Right, then QR will be OR minus OQ. This is positive 12, yeah, and that. Okay, for part 3, explain the geometric relationship between PQ and QR. So if you look at your two answers here that I color in yellow, okay, I think many people can see that you can easily factor out a -2 from your QR, and you would obtain PQ. Alright, so let's do that first. QR is equal to 0 minus 6, 12, which is equal to -2 bracket 0, 3 minus 6. And this will be -2 times PQ. Okay, so we notice that QR is equal to -2 PQ. But in the previous lesson, we learned that if we are able to write a vector as a number times the other vector, that means the two vectors are parallel. Right? We covered this in the earlier pages. So recall that if A is equal to KB for some scalar K, then A is parallel to B. Right, so here we indeed have a vector equals to a number times another vector. That means these two vectors must be parallel. So what they expect you to say is PQ and QR are parallel. Okay, and that's it. Okay, so before you claim that these two are parallel, you will have to show the computation first. Okay, you will first have to show that QR can be written as a scalar multiple of PQ. The QR can be written as a number times PQ, then only you conclude. Okay, so showing the computation here is a compulsory step. You have to show that QR is equal to a number times PQ. Then only you can say they are parallel. Okay. For this kind of question, how much you need to explain is actually depending on the marks given. So if this question only gives 1 mark, in the exam, of course, you will know the number of marks given. If it only gives 1 mark, then stating that these two are parallel will be good enough. And because parallel is the most prominent property. And when one vector is a scalar multiple of the other, parallel is the most prominent property to be stated. Okay. If they give you 2 marks or more, then you might want to explain further. Okay, so what else can you say further? Okay, you can also say the length of QR, length of vector QR is twice the length of PQ. Length of QR is twice the length of PQ because of the -2 there. The QR will be the longer one. Okay, what else can we say? There is this negative. There is this negative. So you can also say that QR and PQ have opposite directions. Yeah, so there are these 3 things that you can describe. If they want you to say geometric relationship between PQ and QR, there's actually 3 things that you can describe. The most prominent one is, of course, parallel. And so if there's only 1 mark given, stating that they are parallel will be good enough. If they give you more marks, then you might want to state the second or maybe the third. Next. Another point S lies on the line that goes through R and P. So in a 3D diagram, it's very hard to visualize it accurately, so we just simply plot 2 points R and P. And so they say point S lies on the line that passes through R and P. And so this is the line that they are talking about. And such that P is the midpoint of RS. P becomes midpoint of RS. That means S must be on the far right. And then only P can become the midpoint of RS. Find the coordinates of S. It will be easy to use a midpoint formula here. P is the midpoint of RS. So you have OP is equal to half times OR plus OS. This is the midpoint formula. The position vector of the midpoint is the average of the position vector of the 2 points at the 2 sides. Then rearranging this, you have 2OP is equal to OR plus OS. What they want is actually OS. Oh, they want coordinates of S, so before that we need to find OS. So OS will be 2OP minus OR. And then now sub in the values. Wait. You better do it slower to avoid careless mistakes. This is 2 minus 2, 6. This is position vector. OS is position vector of S. What they want is coordinate, so you must convert your answer into coordinate form and mention the word coordinate. Coordinates of S is 1, 2, minus 3. If you say S bracket 1, 2, minus 3, it will also be understood as the coordinates of S. Either way. Technically, it should be R. Okay, yeah, but don't worry about grammar, because this is a math paper, not a language paper. Okay. So that's it for example 6. Next is example 7. Relative to an origin O, position vectors of P and Q are given by OP equal to this, OQ equal to this. So usually when you are given information in terms of IJK, you usually want to convert it into a vertical bracket form for easier computation. Whether you write it out like this or not is an optional thing to do. 1x minus 2. Okay, so this part in green is optional to write. I usually prefer to write out the given information in bracket form so that when I do computation later, I find it easier. But if you don't mind referring to the IJK form, then it's fine. So you don't have to write the line in green if you don't want to. Because I'm merely listing down the information. Right. Find the values of x for which the magnitude PQ is 7. Okay. Magnitude of PQ means the length of PQ. Length of PQ is 7. Okay, so first of all, you would want to get an expression for the vector PQ, which is OQ minus OP. Okay, 1x minus 2. Then you are given that the length of PQ is 7. Apply the length formula on PQ. You have minus 2 squared x plus 1 x minus 1 squared negative 6 squared equals to 7. We can square both sides. This is so right hand side becomes 49, and on the left hand side the square root is gone and you can expand the squares. And so rearranging and moving all the terms to one side, you get minus 8 as a constant term. Okay, so this thing can be factorized into x minus 4x plus 2. Okay, and you get x equals to 4 or x equals negative 2. And that's it. Those are the two possible values of x. If everyone is done, I move to example 8. If you need me to wait for a while, please say something in chat. Right. You are given position vectors A and B. Part 1 says find unit vector. So here's the keyword unit vector in the direction of OC. And so this unit vector, how to find it? It will be OC divided by its own length. OC divided by the length of OC. And this is what they want to find. Okay. Right. So you first need an expression for OC first. So you have to make use of this AC equals to 2AB. AC equals to 2AB, which means OC minus OA is equal to 2 times OB minus OA. I express everything in terms of position vectors. Right, then I usually prefer to make OC my subject first before I sub in the value so that it looks less messy. So that I have now OC minus OA is 2OB minus 2OA. OC is equal to 2OB minus 1OA. And then now we sub in the values. Two, 3, and minus 6. Okay. So we are about to divide OC by its own length. So if you like, you can find the length of OC separately first. Some people prefer to do things in one go, so it's actually up to you. Okay, this time I choose to find the length of OC separately. It's 2 squared plus 3 squared plus minus 6 squared. And you get a nice value of 7 units. And then unit vector in the direction of OC. If you don't want to write this long phrase, you can actually write OC with a hat up there, but I find it a bit messy to have an arrow and a hat, so I choose to write the phrase instead. And the hat actually means unit vector. Right, so OC with a hat on top means unit vector in the direction of OC. Okay. So it's actually OC divided by its own length. Okay, so that gives 1 over 7 of 2, 3 minus 6. But it's actually okay to leave it in this form. Right, because 7, 2, 3, and minus 6, all these numbers, they don't have a common factor. Okay, so the numbers actually cannot be simplified. Even if you distribute it inside, nothing becomes simplified. So it's okay to leave it this way. Of course, there's nothing wrong if you proceed and write 2 over 7, 3 over 7, minus 6 over 7. There's nothing wrong if you write this way. Unit vector doesn't have to be in IJK terms. The question doesn't say that you must give in IJK, so it's fine. It's fine to leave it in bracket form. Like if you really want to convert it to IJK form, then it's just 2 over 7i plus 3 over 7j plus, no, the last one is minus 6 over 7k. It will be just like this if you really want to convert into IJK. But since the question doesn't say, so either in vertical bracket form or IJK form, they are equally good. Because this and this, they are actually the same information presented in different formats only. It's the same information. Yeah, so that's it for part 1. Now we move to part 2. OD is given by this factor where k is a constant. You have an unknown constant here. It's given that OD equals MOA plus NOB, MN are constants. Find the values of MN and K. Okay. So you have 3 unknowns involved in total, K, M, and N. By equating vectors, in vertical bracket form, the 3 numbers they are actually coefficients of ijk. The 3 numbers here on the other side, they are also coefficients of ijk. So we can actually safely compare coefficients. When you have 2 vectors connected by equal and written in bracket form, you can compare component by component. It's always safe to compare. Right, so if you compare component by component, you will get 3 equations. And so 3 equations to solve for 3 unknowns, it shouldn't be a problem. Right, so we just make use of the given equation. OD is equal to MOA plus NOB. And then just type in the values. And then on the right hand side, you can combine the 2 vectors. Right, now you have 2 equal vectors and you can safely compare component by component. Right, so we have 4m plus 3n equals 1. Let's call this equation 1. And so when you have, especially when you have many equations to solve simultaneously, it's important to label the equation as 1, 2, and 3 so that people will know what are the operations you do when you solve simultaneous equations. Don't let the reader guess what you do. Minus 2n minus 4n is equals to k. That gives us a third. Okay, so ideally, I would want to use 1 and 2 first. I don't want to involve 3 because equation 3 involves 3 unknowns, while equation 1 and 2 only involve 2 unknowns. Okay, so using 1 and 2 will be much easier. Whether you want to use elimination method or substitution method is your choice. So I'll just continue up here. From equation 2, we can make m the subject. Let's call this equation 4. Then you sub 4 into 1. Minus 5n is minus 15, then n is 3. Sub n equals to 3 into equation 4. That will be convenient. Okay, so m is 4 minus 2 by 3. M will be negative 2. Okay, then at the end, sub the values of m and n. Into equation 3 to obtain k. So k will be minus 2m minus 4n. K will be 4 minus 12. K is negative 8. Okay, done. Right, so if you like, at the end, you can just list down the values of the 3 unknowns, but this will be an optional thing to do. Right? M equals minus 2, N equals 3, K equals minus 8. This is optional. Right, so we are done with example 8. Okay, a few more minutes. We have a few more minutes. We can still carry on a little bit. to the true or false section at the bottom of the page. Yeah. Okay, because we are in a rush of finishing the syllabus, usually I will wait for you guys to respond whether it's true or false, but because of the rush of us finishing the syllabus, I will just tell you the answer straight away. But if A and B are parallel, then A hat equals B hat or A hat equals minus B hat. So is this a true or false statement? Okay, so let's recall, if A and B are parallel, there are actually two possibilities. Okay. AB parallel. And then there are two possibilities. You can have AB having same direction, or you can have AB opposite directions. And there are two possibilities. And so for the case when they have same direction, we can visualize it this way. You can have an arrow A like this and arrow B, a longer one. They're in the same direction. Okay, now, if A and B have the same direction like this, you can always shrink their lengths to become one unit, then you will get A hat and B hat respectively. Okay, so let's say this is a length of one unit, and here's your A hat. Okay, so the vector B, if you shrink the length to become one unit, then it will look exactly the same as A hat. Okay, because when we take the unit vector of a vector, the direction remains the same. Okay, so A hat and B hat will have the same direction for sure because A and B originally have the same direction. Except in this case, because these two vectors have the same direction and same length, then we can conclude that A hat is equal to B hat. That's the first possibility. The second possibility is if A and B are in opposite directions. Here's your A, your B could be possibly longer but in the opposite direction. You can shrink your length of A to become one unit, so that will be A hat. You shrink your length of B to become one unit, that will be B hat. Okay, now these two vectors have same length but opposite direction. Same length, opposite direction means one is a negative of the other. Okay, so you have A hat equals to minus B hat. Okay, so there goes your two possibilities. Okay, so the statement is true. The statement is true. The statement is true because there are two possibilities. Okay, the directions can be the same or opposite. Okay. Next is point number 2. This one I would want you guys to respond. What do you guys think? Is this true or false? Okay, to those who say false, can you tell me the reason why it's false? Okay, so think carefully. A vector A has length 5. Well, the answer is actually false, but up until now, I don't see the. Okay, uh, okay, nobody has stated the most obvious reason yet. So I'm still waiting for somebody to state the most obvious reason. Yeah, the length is not equal to 5. Yes, good. The length of this vector is not 5. And so this is the most obvious reason. Yeah, so it's false. The most obvious reason why it's false is because the length is not 5. So if you check the length of the given A, 5 squared plus 0 squared plus 5 squared, that gives you set of 50, which is obviously not 5. Okay. So that's the main reason why it is false. Okay, what if we are asked to find what should be the correct answer then? Okay, so what should A be? What is the correct A? Okay, so to find the correct A, there is a procedure to follow. So there are actually a few ways to find the correct A. Now I'm introducing to you the method that is most intuitive. Okay, so you are given a vector 1, 0, 1. So I just simply draw a vector. This is 1, 0, 1. Okay. So you can easily find the length, right? This length is actually set of 2. If you do the computation, you will get square root 2. So what we'll do is we'll shrink the length first. We'll shrink the length such that it becomes length of 1. Okay, which means you get the unit vector. Unit vector in the direction of 1, 0, 1. Then the next step is you extend the length. Okay. Extend 5 times. So that you get a length of 5. Right, so this is the procedure that we will follow. So when you extend the length by a factor of 5, if you want to maintain its direction, then what you will do is you just multiply the green color vector by 5. Okay. Now, since this question here, it doesn't say that the direction must be the same as 1, 0, 1. It just says parallel. Right? It just says parallel. So there is a second possibility. There's a second possibility where you can reverse the direction. It's still taking length of 5. Okay. But anyway, what we'll need is the direction, the unit vector in green color. You will need the unit vector in green color. So let's find it. Okay, so first what you can do is you find the length of 1, 0, 1. Okay. That is 1 squared plus 0 squared plus 1 squared. That will be 2 units. Okay. Then unit vector in the direction of 1, 0, 1. This will be 1 over 2, 1, 0, 1. Okay. Let's leave it this way. Okay. Then okay, so A can be either equals to 5 over 2, 1, 0, 1, or minus 5 over 2, 1, 0, 1. Where you just take 5 multiplied. So it just, this thing is just 5 times 1 over 2, 1, 0, 1. Well, this one is just minus 5 times 1 over 2, 1, 0, 1. So you can get the 2 red color vectors. Yeah, so these are the 2 answers. These are the 2 answers. And these are the 2 correct values of the vector A. Okay, and if you really check whether it's correct or not, right? From the visualization, you can see the condition required is having length of 5, which both of our red vector really has length 5, and they run parallel to 1, 0, 1. So the 2 red color vector is indeed parallel to the original blue color one. Because parallel can be either same or opposite direction. So both of the red color vector, they are parallel to the blue color one. And both the red have length 5. So there are 2 valid answers in this case. Okay. We are left with statement 3 and 4. I will leave it for you to think first, and we'll discuss tomorrow. Whether 3 and 4 are true or false, you can think first. We'll discuss tomorrow. Okay, that's all for today. Thank you, everyone. You may leave the video meeting.
Thank you, sir.
Thank you, sir. Have a nice day.
Thank you, sir. Bye, sir.